In this next section, we're going to look at how we use how we use equations to model situations in the real world to answer some questions. So this first one is a sporting event. Nightcliff defeated Darwin in a recent Australian rules football match by a score of 66-52. There are two ways to score points in Aussie football. You can score 6 points by kicking it through the middle posts. This is called a goal. Let A represent the number of goals scored. You can score 1 point by kicking between a middle post and a behind post. This is called a behind. Let B represent the number of behinds scored. Write a literal equation or formula for determining the final score S if you know A and B. Well, the total score S will be equal to, you get 6 points for every goal you score. So we're calling that A. So you get 6 points for goals plus 1 point for behinds. So 1B. We don't need to show the 1. All right, that's a pretty straightforward one. Remember, we're multiplying, so this means that if I scored 3 goals, I can substitute 3 in for A, and that would represent 18 of my points. If I scored 5 goals, I can substitute 5 in for A, and that would represent 30 points. So remember, it's called a variable because we're not specifying how many goals we've scored. We're leaving it open so we can plug in any amount of goals we want and then analyze how many points that would produce. So A represents number of goals scored. 6 is the points per goal. And then 6 times A, this expression together multiplied, represents the total number of points scored through goals. 6A plus B, that expression represents overall total number of points scored throughout the match. The same is true for B. Since behind is worth 1 point, that means I've got 1 times B. I'm putting B in as a variable as a placeholder to say that I can change or I can vary how many behinds I score. So if I score 2 behinds, I can put it in 2. If I score 4 behinds, I can put it in a 4 and I'll multiply that by 1 and figure out the total number of points scored from behinds. And remember, 6A plus B, that expression represents the total number of points scored for the match, and we're going to call that S. So we're going to say that whole thing is equal to S. All right, so in B, Nightcliff won the game by scoring 66 points. They also scored 12 behinds during the game. Find the number of goals they scored. Show all work. So if they scored a total of 66 points, we don't know how many goals they scored. We do know they scored 12 behinds. So I substitute 12 in for B. I've substituted 66 in for S. And now we want to know how many goals did they score. Now it becomes solving equations like we just did in the last couple videos. So I'm going to subtract 12 off both sides. And I'm going to get 54 equals 6A. Divide both sides by 6. And I get A equals 9. So they scored 9 goals. Okay, part C. Darwin scored a total of 52 points. They made 7 goals during the game. And in the equation, okay, so you can read that equation, C represents the number of behinds. Solve the equation for C. So now they're wanting us to figure out how many behinds did Darwin score. So if you subtract 42 off both sides, I get 10. Now, they didn't ask for it in context, so they just said solve for C, so C equals 10. If I write it out, I would say, that Darwin scored 10 behinds. All right, let's look at the next problem. I'm not going to read this to you. You can pause the video here and read it to yourself. Okay, welcome back. So Chad is paying for his cellular bill. How much would Chad's bill be if he used 20 gigabytes of data? So that means that X represents the number of gigabytes that he used. So that means I'm going to substitute that in for X. And solve. Now the C is already solved for. So I'm just going to simplify the right side of the equation, which is everything after the equal sign. Some people want to distribute here often. We don't distribute because Both of these in here are numbers. They're similar terms. I could just combine them to get 10. That's what we're going to do here. We don't want to distribute the 15. We would distribute the 15 if I had like an x plus 10 or something like that, where I can't combine the x and the 10. Then it might be helpful to distribute the 15. So it just depends on the situation you're in. As you saw before in the literal equations, we didn't distribute the m at all. We just divided by all the stuff. So there's different situations. In this case, because I can combine the 20 and the 10, 20 minus 10 is 10, and now I can just do the multiplication, 15 times 10, and then the addition. So how much would Chad's bill be if you used 20 gigabytes of data? It would be $250. So, by the way, when I was making this question, I was going to ask a different question up front. So we can kind of ignore this. He has used 15 gigabytes of data for part A. I decided to change the question a little bit. I just wanted to set up that I'm giving you the formula that could calculate his bill given any usage of data, which is what we did in part A. We can also calculate how much data he used if I know what his bill is, and that's what part B is about. How many gigabytes, so remember, that's what our X represents, did Chad use if his bill was 175? That's what his C is. So now we're going to use that same equation, C equals 100 plus 15 times X minus 10, except this time C is 175. And now we want to solve for X. So X only appears on the right side of the equation. So I'm going to start getting rid of all the other stuff over there. So the first thing for sure is to subtract 100 off both sides. Okay, so I'm going to get 75 equals 15 times X minus 10. Again, here's where you have some choices. X is inside this chunk of stuff. So instead of distributing the 15, I'm just going to get the chunk by itself by saying it's 15 times all that stuff. So I'm going to get rid of the 15 by dividing both sides by 15, in which case I'm left with 5 equals X minus 10, because the 15 divided by the 15 is 1, and 1 times X minus 10 is X minus 10. Now, lastly, I'm going to add 10 to both sides, so I get X equals 15. So that means he used 15 gigabytes of data that month. What's the real world meaning of the 15 in the formula above? How about the 100? So if I look at this formula, what does the 15 stand for? That's going to be the dollars per gigabyte over the allowance. So however many gigabytes he's allowed, every time he goes over, for every gigabyte he goes over, he has to pay $15. So that's what the 15 represents. For every gigabyte over his allowance for his plan, he has to pay $15. What does the 100 represent? The 100 is just the kind of initial starting point, the amount of fees. So the $100 I would call his base charge with taxes and fees. If he doesn't go over his gigabytes, it would just be $100 would be his bill. So it's $100 for the plan that he's on with taxes and fees. Because that's what we would call our starting value. Okay? I'm going to ask one more question. What's this 10 doing here? What's that about? Well, that's a little more interesting to look at here. So the 10 is I'm putting in for X the number of gigabytes used. What if he used exactly 10 gigabytes? 10 minus 10 would be 0, and 0 times 15 would be 0. There would be no overcharge, right? So that means he wouldn't have gone over his bill. What if he only used 5? If I put in a 5 here, I get negative 5 when I do 5 minus 10. And then when I do negative 5 times 15, we'd get a negative number. We'd start subtracting off of his $100, and the money would go down. So we're going to say that the domain for this function is all x values that are bigger than 10. Because if he uses 10 or less, we don't even need this formula. We know that the bill is just $100. This is only for when he goes over. So if he uses more than 10 gigabytes of data, we plug it in for x, and then the first thing we do is x minus 10. So 10 seems to be the allowed gigabytes because we subtract, those are the allowed gigabytes, and we subtract the gigabytes he used to see how much he went over. So if he used 13 gigabytes, when we do the 13 minus 10, we get 3. That means he went 3 gigabytes over, and then the 3 times the 15 is how much overage he has to pay. So the 10 is the allowance of gigabytes per month.